All right, question 4. Exercise 13D, we're going to be solving. So let's do question 4. I'm going to show you the gist of it. And then once you got the gist of it, you can have a go with these past exam questions from year 12. So we go, question 4. We're starting off with A. We've got the problem as 4 times 2 to the power of 2x, close brackets, is equal to 8 times 2 to the power of x minus 4. Okay? The trick in this problem here is to see that you've got the 2 to the power, or base 2. That's the main thing that makes it look tricky. Okay? And the trick is here. See that 2 to the power of 2x? Another way of visualizing this using your index law number 3 is this is the same thing as running 2 to the power of 2, so 2 squared, all to the power of x. Okay, and the reason why I know that is because 2x is the same thing as saying 2 times x, and I'm using rule number 3. If you're timesing the two powers, then this is the only rule that you can do. You can split it up. But the special thing is, if it's 2 to the power of 2 times x, which can be written as those brackets, it doesn't have to be 2 inside the brackets. In fact, you can rearrange it and write it as 2 to the power of x all squared. See, that's the same thing. And that's the one little trick. And the more you do of these problems, the more you pick up on it. If you didn't ever see this, then yeah, the approach seems really tricky. But once you've done that, now that I've rearranged it for you, this says that the problem is now 4 times 2 to the power of x squared is equal to 8 times 2 to the power of x minus 4. What I'm going to highlight is the fact that they both have a 2 to the power of x. That's why I want to rearrange it. Okay. Some of us may still look at that and go, I still don't know how to solve that. That's pretty nasty. Some of us will do what typical end of year 12 students in those exams would do. They would do 4 times 2 and then 8 times 2. And that you can't do because BODMAS, we always said brackets before indices, before division, multiplication. You can't just do multiplication without worrying about the indices. So a lot of students do 4 times 2 just because they don't know what to do at this point. They'll just do 8 to the power of 2x and then 16 to the power of x minus 4. And they carry on, and that step already, you'd lose marks. So you get 0 straight away. Okay? So how do you do this problem? Here's the tip. When you see something similar like that, if you got to this step, that's really good already. I would say, to make your life easier, introduce a new variable. So let, I don't know, use the letter t, for example, equal to 2 to the power of x. Why do you do that? Because it simplifies the look. The look now becomes 4, instead of 2 to the power of x, it is now t squared. That's much easier. 2 to the power of x, if I replace with the letter t, it becomes t squared. This is now 8 times t minus 4. Suddenly, that feels more achievable. That's something that you might have seen before, something that you're more comfortable with. So I'm just going to press enter to give myself a bit more space. Here we go. So let's go back up. So now I've got something that looks more like a quadratic problem. This is where, depending on your quadratics, hence why chapter 3 was important at the start of the term 1, whether you can solve quadratic problems here. I would have minused and moved every term to one side. So here you should have 4t squared minus 8t plus 4 is equal to 0. And all I've done there is minus 8t on both sides, add 4 on both sides. Okay, balance in the equation. Now you've got a quadratic problem. Factorize. What does that factorize to? So I can see that they all have a common factor of 4. Take out 4. T squared minus 2t plus 1 is equal to 0. See if I can factorize this now. And that's where chapter 3 comes in. So if I use chapter 3, 4 bracket, 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 bracket equals 0. T, and you can see here it's minus 1. Okay? If you solve for it using null factor law, this means that either t minus 1 or t minus 1 is equal to 0. So which one is the solution? Well, both of them are the same thing. So t minus 1 is possibly equal to 0. Therefore, t equals 1. If you've done up to this step, you've only got 1 mark out of the 3. Well, in this case, actually, it's probably only 1 mark out of the 2. What haven't I done yet? What am I missing? Why am I not done yet? I've got t equals 1. I've solved it. What's the problem? Matt?
I have substituted back into 2x.
Very good. The problem was asking you to find x, not t. I made up t to make it easier for me to solve, but you still need to solve for x. So this is where you would then say, since t equals 1, well, t, we made up over here. We said t is equal to 2 to the power of x. So here, I resubstitute it. It's 2 to the power of x is equal to 1. Now I'm meant to solve for x, and 2 to the power of what will give you 1? 0. So naturally, I know x has to be 0. But how do you actually do this? Sometimes you get a problem where you can't just solve it. How do you solve for x at this point? Solving by comparison, you can write this as 2 to the power of 0, which is 1. Doing by comparison, if bases are the same, they both have the same base, then that means the powers must be the same. Therefore, x equals 0. So that's another technique. Okay? Now this is not a typical exam question because you end up with only one solution here. The 3 marker, you're going to get 2 different answers and one of which you have to reject. Okay, that's where you get your 3rd mark from. Because one of them doesn't make sense. One of them is not possible to solve. And that tests whether you understand in exponential functions what are the restrictions. That's the difference. Okay? So that's how you would solve this type of problem. So when you do question 4, all of these require you to replace those 2 to the power of x or 3 to the power of x, and then you use a quadratic problem there.
For the ones that you reject, would they always be like plus t, something plus anything? Because then you have to get a negative number, but if you square something, you can't get a negative number. Well, if anything is absurd, you can't get a negative number. Unless the base form is negative.
Sorry, just to clarify what I'm understanding you're asking. Are you asking when it doesn't work? Is that what you're asking?
Yeah.
Yeah. And go describe it to me.
So if it was like, so the solutions were like x plus 1, the x would have to be negative 1, and then you can't get negative 1 from the 2x, which is the power of x.
Very good. Why?
Because unless the base form is negative, anything to the power of something, even if it's negative power, it can't be a negative number.
Very good. And even if the base form was negative, can you get negative 1?
No.
Say I got negative 2 to the power of x equals negative 1. Is that possible?
Yeah.
How?
Because you just multiply by 1. You can't. No, you can't do it. Because you can't find like the log of a minus negative number.
Why?
Well, because even if you change the exponent to a negative number, it would just make it closer to 0. You increase it and it just goes to infinity.
Very good. And that's what Dylan was saying. If some of you have just gone, I don't know what he's talking about, that's the key thing that you need to understand in chapter 13. So I can teach you the algebra and you will know how to do this, but what they're testing at the exam is they're testing how well you understand the functions. What he's describing to you, for those eventually you'll understand, is that exponential graphs look like that in general. Okay? And what he's trying to say is that the numbers will infinitely get smaller and smaller and smaller. It's getting to an asymptote. So hence why it always approaches as close to 0, but will never equal to 0. But then on the other hand, it goes on infinitely large. What he's trying to say is it's never possible to even get a negative number. There will never be a negative number, 2 to the power of anything or 3 to the power of anything. It is not possible to get a negative number. Okay, and that's what they're looking for. Hence, as soon as you get a negative solution, yes, you're right. You're meant to reject it, and you're meant to say something like, since x is greater than 0, so that's as an example, therefore, and then you write your answer. Okay, so that's what the step they're looking for, and the explanation for it this year and the next years, they might be looking for open-ended responses. But yes, to answer your question, yes, it would have to, you can't have a negative value, and that's the key thing to look for. Yeah. All right, now, you've got the idea of how to do this type of problem. Let's try this exam problem. This is a year 12 exam 1 of back in 2014. This should be doable. So this is essentially the first part of your exercise 13D. If you can do 13D, you should be able to do this. The only thing I can see why students make a mistake, it's your negatives. It's your algebra. So have a go. This is 2 marks. Let's see if you can get 2 marks, making sure that your method is correct. If your method is wrong, your negatives are going to be wrong. Question, method, answer. Don't try to skip steps. Have a go. 2 minutes means that you always times it by 2 marks means that you times it by 1.5, so you should take 3 minutes. It is currently 10:40. Yep, 10:40. You should be able to do this in 3 minutes, maximum. 3 minutes. Let's go, 10:43.
For the indices part, could you just use it as algebra and take the 3 out and then turn the 3 into a?
Take out the 3.
So the 3 on both sides. So it becomes x 3 bracket x minus 1. And then
Like that?
yeah. Yeah, kind of, yeah. And then you get that final bit, and you can find the next one.
Maybe.
Alright, so it doesn't.
Yeah, that's how you do it.
Oh.
Have a go, 3 minutes. This is testing. Everyone should have this. Remember, exam 1 was designed for you to get marks. This is a question 4. There are 10 questions in exam 1, so you're 40% of the way, and they're trying to give you marks. That's why math is not meant to be hard. It's meant to be doable, providing that you've got your junior mathematics down. So work on your algebra. Take your time. It was designed for you to succeed. If you can't succeed in exam 1, you have very little chance of succeeding in exam 2.
No, 2 to 3. Right.
Oh, yeah.
Right there. Right.
Have a go.
So this is 8.
This should be doable.
So 8 times this. And
1 more minute.
Makes that, since exponents are there, you don't multiply exponents, so this is
Once I show you the solution, you're going to try the 2013 version. Same idea. And once you've got that, then you might want to try 2011. 3 marker.
the same base of 2. You can equate the exponents to each other and solve that. So
6 minus 3x.
3x minus 3 is equal to 2.
3 minus 3 is, yes. You leave it after.
Like, either way.
What? I'm doing wrong.
All right. Time's up. Here we go. First step. In these exponentials, you want to make the bases the same. Make the bases the same as currently base 2. I'm going to keep this as 2 to the power of 3x minus 3. Change the 8. The 8 is 2 to the power of 3, because that's what 8 equals to. Then you got 2 minus x there. This is where some students will make a mistake depending on their algebra. So notice when you're expanding, it's 3 times not just the 2, but it's also 3 times the negative x. That's where most students will make a mistake. So when they're writing their solutions, if they're not writing it clearly, say this is 2 to the power of 3 times 2 minus x. Okay, if you do it that way, then you're more likely to write it correctly, and it's minus 3x. If you get it wrong, it's simply because you wrote 6 minus x rather than 6 minus 3x. That's the most common mistake. Okay, so here we've got 2 to the power of 3x minus 3, and then now you can say, since the bases are the same, therefore powers must be the same. So these powers must be the same. Hence, you can now say, therefore, 3x minus 3 has to equal to 6 minus 3x. Add 3x on both sides. Add 3 on both sides. And x equals to 9 on 6, which is 3 over 2.
How you got what? Wait, everything was right. Wait, man. Can you like read it?
I'm just going to write it again.
I like can't find it now.
This bit, yeah. So x equals to x.
There you go.
equals
2 marks.
Oh yeah, because it's adding and not
Okay, so it's that idea, you're solving by comparison. If both of them are equal, both of the same bases, that means the powers must be the same, and that's the step. Now, if you didn't expand it correctly, that step there would have been wrong. So as long as you've got the correct steps, you should be fine. So same thing, 2013. Have a go. Same idea. Not that different. Remember, they must have put it into 2014 because a lot of students couldn't do it. So they put it again in 2014. Once you guys do it well, they will not put it in the exams again. Okay, they'll just keep doing it until you get better. So that one, 2013, 2014, technically it's the same and very similar technique.
What does that say? -6, 9, Thanks, Dad.
Very similar to before. Same idea. So if you can change the bases the same way we did before, you should be able to do these. And it's 2 marks again. I believe this was question 2B. So remember, there are 10 questions in exam 1. They're all add up to 40 marks. Yeah, it is. It's designed to be easy, yet the average is not even 50%. Okay, it's crazy. That's what I'm saying. Get your junior maths right. The better you train the algebra, the more you're ready for this. Exam 1 was designed for you to get at least 80% onwards. You should be.
-18, I got -4.
What? So what's the answer?
I don't know. I haven't solved it, but
-6.
let's see.
In my head, I got it wrong.
Oh, whoops, yeah, no. That's right.
You're right.
Yeah. So, yeah, that's it.
Oh, yeah, I got it wrong.
I forgot to do this. I forgot to add 2 5 6. I just did just like that today.
Hands up, you got -6. Cool. 2 marks. Very easy to do. Now remember, that is almost a decade ago, so you won't be expecting these type of questions. But that's why I'm saying when you get there next year, keep doing the past exams. You'll start to see the patterns to it. Look at the assessors reports. You'll be able to tell, your teachers should be telling you what's likely to come, and they will tell you and train you the skills that you need. Because whatever the year before couldn't do, so this year, 2022, if the cohort couldn't do a particular question and the percentage is very low, you can bet it will be on your exam in 2023. That's how you predict
So
it.
wouldn't the trend be a bit faulty now because of like COVID? Because that wouldn't be
We
able
going
to do
down.
anything.
Yeah, it could be. Yeah, it might be easier. Who knows? But I had a look at the exams in the last 2 years, and I think they've kept it relatively same difficulty. So I don't think it's any harder, but it won't be this easy anymore. All right, let's see how good you guys are now. This is the 2011, definitely more than 10 years ago, 3 marker. A 3 marker question. 3 marker question, have a go.
Wait, so do you use the variable t or do you use like
You can use any. I use A usually.
Why did you use t before?
I used it because I just wanted to prove a point. You can use any letter.
I see. So it's arbitrary.
Arbitrary. It's just to help you visualize it. Some people don't use it at all. I just do it so that you guys can see easier. If you can have a go with this one, it's the same thing when you do logs. So there's a log version. I just haven't taught you logs yet, so I can't show it to you. But once you know logarithms, they do exactly the same, but with logs. Every time you see a 3 marker, you know straight away.
It's like there's 7 equations or something like that, and then you want
3 marks times 1.5, so
the hardest equation.
4.5 minutes for this question, maximum.
Everything is I'm solving.
Change everything.
4.5.
Bro, you said, yeah, it's such like the 7 equations.
I don't know if it was 7 instead of that.
7 equations, 7 more.
Should be able to transform it into a quadratic problem. You get a mark for transforming into a quadratic. You get a second mark for getting the correct possible x values. And then you get your final mark for justification. 3 marks.
Or the random price problem. So one of the millennials.
Oh, is it called my
Price problems.
Bro,
There's $1 million for each problem.
really?
Yeah. It was then that whole life problems.
Oh, what would we have?
Well, I leave it on.
Name the Stokes existence and smoothness. Hodge conjecture.
P versus NP.
Solve the probability.
Solve it right now. And solve the Riemann hypothesis. You actually will.
The Yang Mills.
There's one between them.
Yang Mills existence of Mar and Pascal. Bro, these people are like honestly.
And let's go.
Us
Scan out whole lives to solving the problem.
That's 2 marks there. That's 2 marks. Turning it into quadratic, finding the correct solutions for them, or possible solutions.
Really? Yeah, he's doing for society.
Wait, what?
Yeah, he solved all the problems and rejected the money.
And everyone rejected the money.
Yeah.
So he's an idiot. Going back to the
There you go. Those are the solutions for the 3-marker 2011. That's the level that you should be getting at, and that's all within this question. If you want to practice that, that's question 4 of exercise 13D. The rest, that's what you were practicing. So exam 2013 and 2014 were based on whether you can do these skills. If you can do those, then you would have been able to do those exam questions. And then if you can do question 4, then you could have done that question for exam 2011. Okay? But what I'm trying to show